Hello everyone, welcome to the next lecture on the numerical analysis. Today I will explain you how you can solve the system of the nonlinear equations with the help of the Newton Raphson method. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the numerical analysis. In this playlist you can see I have uploaded the various lecture on the content of the numericals such as Newton Raphson method, Gauss eliminations, also their MATLAB code of the each topic I have explained in this playlist. You can subscribe my YouTube channel so that when I upload in my next video, you will get the notification. So what we have discussed in our last lecture, we have defined the Newton Raphson method for finding the root of the equations, and the iterative formula is defined as this case. This lecture you can easily see in my playlist, and you can see this is the Newton Raphson methods for examples part 1 and the part 2. Now the objective of this lecture, we can find how you can find the solution of the equation when you have the more than one equations. For example, f1, f2, f3 and fn, such that each of the fi's are my continuously differentiable. Now what is the target of this today's lecture? Your target is to find the value of x1, x2 and xn. This is the target to find the value of the x1, x2 and xn such that when I substitute the value of the x1, x2, xn in the function f1, it is approximately 0, f2 is also approximately 0 and so on. So that is the objective of this problem. Now since it involves more than one equations, so firstly I will explain you with the help of the two equations, that is f and g, and later on I will explain you with the help of n equations. I hope you can like and comment on this video to support my efforts. Now since it is a Newton Raphson method, so it starts with the initial guess. So I consider the x naught and y naught is my initial guess. Then your target is to find the new point x1 and y1, which is defined as x0 plus h and y0 plus k. So that means your basically target is to find the value of h and k. Fine. Now your target is to find the value of h and k such that x1 comma y1 is the root of the equation 1. Fine. So what will happen if x1 and y1, that is x0 plus h and y0 plus k, is the root of the equations? That means this point will satisfy my equation number 1. And f and g are continuously differentiable, so we can apply the Taylor series to expand the function f and g. So I can expand the Taylor series at the point x naught and y naught plus h times the partial derivative with respect to x, k times the partial derivative with respect to y, plus the higher terms. If I neglect all those higher terms, then your expression becomes this system. Fine. And your target again in this category is to find the value of h and k. If you closely look about this system, it is nothing but my ax is equal to b. Fine. Where x is my the unknown variable, h and k, b is my coefficients and so on. So I call this is my j, jx is equal to b, where x is my h comma k and j, what is the j? That is the coefficient of the h, partial derivative f with respect to x, partial derivative with respect to y. And since b is on the right hand side, I can put this value on the right hand side. It is my minus f. This j is called as Jacobian matrix. Fine. Now once you know this is a Jacobian matrix, when this system ax is equal to b has a solution. When this system has a solution only when determinant of a is non-zero. So we can see the determinant of j is my non-zero. Then you can solve this system either by using the matrix method. Fine. You can solve this problem either with the help of the Kramer method. You can solve this problem either with the help of the Gauss elimination method. Fine. You can solve this system either with the help of the LU decomposition method. Fine. So I will explain you what is the matrix method. We all know if ax is equal to b, then what is my solution? Solution is A inverse B. So in that case, my solution is x is equal to j inverse b, why b is my this. After finding the value of the h and k, we can find the new solution as x1 and y1. This is the first method you can solve with the help of the matrix method. There is another way I can solve this problem with the help of the Cramer rule. What is the Cramer rule? How you can find the value of the h and value of the k? That is 1 over the determinant, fine, into I can replace the first column with the value of the b minus f into minus g, and the rest value are same, minus g, del f. And similarly for the k, I can replace the second column with the value of the b. Fine, the first value is my same. Fine. Now once you know the value of the h and k, I can find the new approximation as x naught plus h and y naught plus k. Now again, based on this new pair x1 and y1, I can again compute the value of the h and k at the point x1 and y1, and we can repeat the process until the desired accuracy met. This is the system for the two equations. If you have the n number of the equations, then you can do the same way. You can write the equation, this j is my Jacobian matrix. Fine. How you can define the Jacobian matrix of the n variable? I can write as the f1 with respect to the all, f2 derivative with respect to all, and this is the n cross n matrix. Fine. Now I will explain you all this process with the help of the 7 to 8 numerical examples in the easiest way. Now first of all, what is the steps involved then? Don't forget to like and comment on this video. I will explain you the 3 steps. First step is you have to compute the value of the function f at the given point x naught y naught. Then you can find the Jacobian of the values. You can compute the Jacobian of the matrix J by taking the partial derivative of the f at the point x naught y naught. And finally you can find the value of the h and k by using the Cramer. Once you find the value of the h and k, I can take the new approximation as x1 and y1. And then we can repeat the process until we will get the required accuracy. Fine. So now let's start with this first question. Now in this question it is given that you have to perform only the two equations. Fine. And the given functions are my. Now clearly say these are my two functions. I call the one function is my f, second function is my g. Make sure student the right hand side must be 0. If my first function is written like of this manner, then you have to firstly convert them so that the right hand side is 0. Now you can find the Jacobian matrix. What is the Jacobian matrix? Because it's a two variable, so we can write this function. What is the partial derivative of f with respect to x? So 6 yx minus 10. Partial derivative with respect to y, 3x square. Partial derivative of g with respect to x, 0. Partial derivative of g with respect to y is 2y minus 5. Fine. Then your target is to find the value of the h and k. So the value of the h is 1 over determinant of the j into I can replace the first value with the value of the minus f minus g into 3x square 2y minus 5. And similarly for the k, I can replace the second column with the help of minus f and minus g. Fine. Now let's start with the first equation. So what is the step number 1? Your target is to find the value of the f and g at the point of x naught, y naught. So if I substitute the value of the 0.5 and 0.5 in these equations, you will get 1 over 2, 1 over 4 minus 5 plus 7. Fine. Similarly for this case, it's a 1 over 4 minus 5 over 2 plus 4. And you can solve this calculation, you will get the answer as 2.375, 1.75. Step number 2, you can find the Jacobian matrix. Find the determinant of the Jacobian matrix. I can substitute the value of the 0.5 and 0.5 in this case. So it will be 6 into half into half minus 10. So 3, 1.5 minus 10. It's minus 8.5. 3x square 0.75. 0. 2y minus 1 minus 4. Can you find the determinant of this? It is my 34. Fine. The value of the j is my 34. Now can you find the value of the h? It is 1 over determinant. I can replace the first column with the value of the minus of the f, minus 3.75 minus 1.75, and the value of this case is 5. Fine. Now what is the value of the determinant of j? It is my 34. I can substitute this value as my 34, and then you can solve the determinant of this 2 by 2, and then you can get as this answer. Make sure, students, first of all, one is the most important thing. Now in this question you can see, are they talking about how many decimal places you are needed? They are not talking about the decimal places. So by default you can pick as the 3 decimal places. Fine. You can calculate the result up to the 3 decimal places, and whenever you want to calculate the 3 decimal places, do all the calculations up to the 5 decimal places. Fine. If you want to calculate the result up to the n decimal places, do all the calculation up to the n plus 2 decimal places. So that's why I have calculated all these values up to the 5 decimal places. Similarly, now you can find the value of the k. I can replace the second column of the j with the minus f and minus g. Hence, the new value of the x1 is x0 plus h, and the value of the y1 is y0 plus h. x0 is my 0.5, h is my 0.31801. Similarly, y0 is 0.5 and k is my 0.43750. Now clearly say there is up to the 3 decimal places, they are not exactly same. I can compute the equation 2. Now in this equation I can consider the value that we have obtained as x1, y1. Now again, your target is to compute the value of the f at the point of x1, y1, compute the value of the g at the point of x1, y1. I can substitute the value of the x1 and y1 and you will get f and g this point. Find the determinant of the j. I can substitute the value of the 6x1. This is my x1 into y1 minus of 10 and 3 of the x square is a 3 times 0.81801 square and so on. So after substituting this value, you will get the result as 67.87. Similarly, you can find the value of the h. H is my 1 over determinant of j. I can replace the first column with the negative of f, negative of the g. Fine. And the second column is remain same, 00744 minus 3.12500. I can substitute the value of the determinant of the j this. You can solve, you will get the result. Similarly, for the value of the k, I can replace, because k is related with the y, I can replace the second column with the negative of the f, and negative of the g, and the first column is remain same, minus 0.539867 and 0. Now again you can substitute the value of the j and you can get these two expressions. So therefore my x2 is my x1 plus h, y2 is my y1 plus k. So I can substitute value, you will get after the second equation. Now since the question suggested you have to perform only the 2 equations, so I have obtained the first equations and the second equations. Fine. Although it is, again you can see up to the 3 decimal places they are not same, but they are asking you to perform the 2 equations. So therefore this solution you can obtain up to the 3 decimal places. Can you convert them into the 3 decimal places? So your solution will be 0.971. You can round off them and it is 0.999 is the right answer of this problem. Look at the second question. Find the solution of the system of the equations correct up to the 3 decimal places. That means you will do all the calculations with how many decimal places? With the 5 decimal places. But you can see in this question, the initial point is not given. Is the initial point is given to you? No. Initial point is not given, but you can see in the previous example, the initial point is given. Fine. So let's say, firstly, you can write the Jacobian matrix. Can you find this Jacobian matrix of the f and g? F with respect to x, 2x, f with respect to y, 2y. F, g with respect to x, g with respect to y. Fine. Now, since the initial point is not given to you, you can assume the initial point as on your choice. You may consider the initial point as 1 and 1. You may choose the initial point as a 0, 0. You may assume the initial point as a 0, 0.5. You may assume the initial point is a minus 0.5 and 0.2 and so on. Fine. But I will suggest you the easiest way. You can assume the initial point, one value you can taken as a 1 and another point you can see from this case. I can easily consider the another point is 1 so that this equation will be satisfied. But there is no hard and fast rule. You can assume any of the value if it is not given. But most of the cases it is always given to you. Fine. Then I can start with the initial point 1 and point 3. Can you find the value of the f at the point of x naught, y naught? You can find the value of the g at the point of x naught, y naught. Now you can read the statement again. Your target is to find the solutions. Fine. Whether they need a 2 equations, whether they need a 3 equations. Now, can you find the Jacobian? So what is the j? What is the j? Twice of x, that is my 2. Twice of y, 0.46. Y, 0.243, 0.23. And this is my x. Fine. Now, can you find the determinant of this? If you find the determinant, you will get as up to the 5 decimal places. Similarly, I can substitute this value at this point. H is my 1 over determinant. I can replace the first column with a negative of this. So minus minus plus and this is 0. And the second column is my same. Fine. I can substitute the value of the mod of j is my 1.89420. Similarly, the value of the k is my 1.89420. I can replace the second column with a negative of the f and negative of the y. And first column is my same as of this g. Now you can find the determinant of this and you can get the answer as minus of this. Therefore, I can find the value of the new x1 and y1 is x naught plus h, y naught plus k. Now clearly say the previous value and the new value up to the 3 decimal places, they are not same. Then we can move on the second equations with the value of x1, y1. You can compute the value of the x1, y1. You can find the value of the g at the point of x1, y1. Compute the matrix J at the point of x1 and y1. Compute the value of the h. It is 1 over determinant. All those calculations you have computed up to the 5 decimal places. I can replace the first column with the negative of the f, with the negative of the minus minus plus 00029. Second column is my C, 1.03542. You can find the determinant with the calculator and you can divide it by h. You can get this answer. Similarly, for the k, you can replace the second column of the j with the negative of the f and negative of the k. Now you can find the new solution as, now clearly say up to the 3 decimal places 1035, they are not same. Then again we can compute the third equation. Again you can find the value of the f at the point of x2, y2. Find the value of the g at the point of x2, y2. Now you have to write this value up to the 5 decimal places. This is my 0, this is my 0. Now since f and g both are 0, that means at these equations your step will be stopped and you will get the right answer. Fine. Again you will calculate the value of the j at the point of x2 and y2. You can calculate the value of the h. So what is the h? First column you can replace with the negative of the f, negative of the g. Fine. And you can see that once you can find the determinant, it will be 0. Similarly, h and k are 0. So what is my x3 and y3? Both are my same. Now clearly say up to the 3 decimal places, the value of the x are same, value of the y is also same. Hence, you can convert them up to the 3 decimal places. It is a round of them is a 5 and it is my 2 is the right. Look at the another question. The system of the equations are given to you. One initial point already given to you. This equation I consider as the f. Second equation I can consider as the g. Then you can write as the Jacobian matrix. Can you find the Jacobian? Can you find the derivative of the f with respect to x? It is 2x over x square plus y. Can you find the derivative of this with respect to y? It is 1 over x square plus y plus 1. So I can take the LCM. It is x square divided by this. Can you find the derivative of the g with respect to x? It is 1 over root 2x plus y. Fine. And so on. Now, the initial points are given to you. Fine. I can start with this case. You can find the value of the f. You can find the value of the g at the point of 2.4 and minus 0.6. Compute the determinant of the matrix J after substituting the value x naught and y naught. So it will be 2 times 2.4 divided by 2.4 square plus 0.6 square. How many decimal places they are asking you? They are asking you the 4 decimal places. That means your calculation are needed up to the 6 decimal places. So I have, you can see, I have computed up to the 6 decimal places. Now you can find the value of the h. Value of the h is 1 over determinant. I can replace the first column with the negative of the f, negative of the g. Now you can solve the determinant divided by this, you will get this expression. All those calculations are up to the 6 decimal places. Similarly, with respect to the k, you can find this expression. Hence, you can find the new solution as x1 and y1 as x0 plus h and y0 plus k. Now clearly say up to the 4 decimal places, the value of the x are not same, then we can move on the second equation. Again, I can find the value of the f at the point of x1, y1. I can find the value of the g at the point of x1 and y1 up to the 6 decimal places. Again, I can find the value of the j after substituting this value in this expression, twice of this and so on, and you can solve this expression, you will get the determinant. Again, you can find the value of the h is 1 over determinant. I can replace the first column with the negative of the minus f minus of g. Similarly for the k. Based on the h and k, I can find the solution of the x2 and y2. Again, you can see up to the 4 decimal places, 4, 1, 2, 5 and up to the 4, 1, 2, 5, they are not same. Fine. Then we can move on the third equation. Again, compute the same procedure as a f and g. Now you can see both the values up to the 6 decimal places, they are 0. So that means after the end of the third equation, we will get the solution. The value of the Jacobians after substituting in this expression, the value of the h we have obtained as a 0 because the first column is my 0. Second column of the k is 0. So therefore, x3 and y3 are obtained this manner. And clearly say up to the 4 decimal places, all the values are my same. Hence, my solutions up to the 4 decimal places, you can round off them. You can say it is my 5. So the round off is my 2. If you round off them to the 4 decimal places, it is my 9. So up to the 4 decimal places, we will see the right answer is this. I hope you can like, comment and share this video with your friend as well. Now look at this another question. Now this is a question related to the sine and cosine. Initial solution is given to you. You have to do all those calculations up to the 2 decimal places. So that means your target is to do all the calculation up to the 4 decimal places. Fine. Now firstly, I can take this is my f, this is my g, and try to find the Jacobian matrix. What is the f with respect to the x? It is minus y square sine of x y. Can you find the derivative of f with respect to y? It's a product rule. It's a cos xy minus xy into sine xy. Can you find the derivative of g with respect to x? It is y cos xy plus 1, and for this case it is x cos xy minus 1. Now since the initial points are given to you, fine, so I can start the first equations at the point 1, 2. Can you find the value of the f at the point of x naught y naught, value of the g at the point of x naught y naught? But make sure student, because this involvement of the cos, it is my cos of 2 plus 1. Whenever you are trying to calculate the value of the cos or the value of the sine, always set your calculator in terms of radian. Fine, because this value is my 2 is in the radian, so you can calculate the value of the cos, you can calculate the value of the sine, fine, in terms of the radian. And after the calculation you will do all this calculation up to the 4 decimal places. Similarly, you can find the determinant of the u of the j. I can substitute this value is a minus 4 sine of 2. Once you can calculate the value of sine 2, make sure you have to calculate in terms of radian. Then again the same procedure, I can calculate the value of the h. I can replace the first column with the negative of the f. This is my negative of the f. This is my negative of the g. And the second column is my same. After finding the determinant, you will get the value of the h is 0.0797. Similarly, for the value of the k, I can replace the second column of the j with the value of the minus f minus g. Hence, the value of the x1 and y1 is my this. Clearly say x0 and x1 are not same up to the 2 decimal places, we can obtain the second equation. Again, compute the value of the f and g at the point of x1 and y1 in terms of the radians. Find the Jacobian matrix, find the determinant of the Jacobian matrix. After substitute the value of the x1 and y1, you will get as 5.0875. Find the value of the h, find the value of the k as I discussed same. You can calculate the value of the x2 and y2. Clearly say up to the 2 decimal places 0.07, they are not same. Fine. Although the second value are same, but the first value is not same, then we can compute the equation third. Again, compute the value of the f and g. Now, since your target is to compute up to the 4 decimal places, and this value up to the 4 decimal places you have obtained as a 0. Compute the value of the Jacobian, determinant of the Jacobians, and the value of the h and g up to the 4 decimal places. You can write this number. You can see in your calculator up to the 4 decimal places are by 0. So therefore, what is the value of the x3? What is the value of the y3? Is this. And you can say that up to the 2 decimal places, the value of the x is same, the value of the y is also same. Hence, my solution up to the 2 decimal places, you can round off them. The last equation up to the 2 decimal places, this number you can round off them to the 1.09. This number is 1.94. It is 4. It is my same 1.94. Look at the another one. In this case, they are asking you perform only the 3 equations. Fine. Again, the similar way, based on the f and g, you can find the Jacobian matrix with respect to x is a 2x plus y, with respect to y x plus 2y, g with respect to x 3x square, it is 3y square. Fine. Initial points are given to you, and how many decimal places they are asking, they are not given to you. So if you are doing all those calculation up to the 3 decimal places, that means you have to do the calculation up to 5 decimal places. Fine. So now you can calculate the value of the f up to the 5 decimal places. You can find the Jacobian of the matrix J at the point of x naught and y naught. So what is that? Twice of x naught plus is a 3.5, x plus 2y, it is my 2.5, 3 times of the x square, 3 times of the y square. All calculation up to the 5 decimal places. You can calculate again h and k based on this. I have to replace the first column with the value of the minus f minus g. Find the determinant. Similarly, find the value of the k. Hence, x1 and y1 are obtained. This. Now you can, because in this question you have to perform the three equations. Again, find the value of the f, find the value of the g at the point of x1, y1 up to the 5 decimal places. Find the Jacobian matrix, find the value of the h and k. That is a similar task, you can do it by on. Therefore, x2 and y2 are by this. Now, since the third equations, again you can do the same calculations. You can repeat the calculation for the f and g, calculate the value of the j, calculate the value of the h and k. So therefore, your x3 is my this number. Fine. Now, since the question are asking you perform the 3 equations only, although you can see up to the 3 decimal places, they are not same. And if you want to calculate the x4, y4, if you want to calculate the x5, y5, then you will get the 3 decimal places correct answer. But anyhow, in this question, they are asking you to perform only the 3 equations. So what is my solution after the 3 equations? You can round off them. What is that? Up to the 3 decimal places. It's a 6, then this number is 3, and if you round off them, it is my 0, 0, 1. What is that? If you round off them to the 3 decimal places, now this number is 7, 7 will be my 9. So 0.999 is the required answer of this problem. These questions are exercise for you. You can see that I have given the 5 examples for you. For the first case, you can consider this is my f, this is my g, initial points are given to you. In this case also the initial points are given to you. All these cases initial points are given to you. Make sure students for this case sin x and cos x, you have to calculate in terms of the radians. While in this case the initial point is not given, then what you can do, you can choose any of the value. You may choose as a 0, 0, you may choose as a half, half, or you can choose any of the value which are near to their point. So based on these solutions, you can try it yourself and let me know in the comment box if you are understanding this lecture very well. So I'm waiting for your comment in the comment box. Till then, you can like, share and comment on this video. We will see the next lecture on the Lagrange interpolation. I hope you can share this video with your friends. Happy learning always, and don't forget to subscribe my YouTube channel. Best of luck students. Happy learning.